Hello students. Now this problem we have. Now the problem states this: the joint frequency function of x comma y is given to be this: f of x comma y equal to a e raised to power minus x minus y when x greater than or equal to 0 or less than or equal to 0. Next condition of y greater than 0 less than infinite, otherwise the value is 0. Here five things we are to find out. First we have to find the value of a, second one find the marginal density function of x, and third one find the marginal density function of y. And fourth one we have to check whether the random variables capital X and Y are independent or not. And fifth one we have to find the conditional density function of y when given x equal to 2. Now first we are going to solve here. Now first of all, we know very well that the area under this joint density function frequency, that is 1. So we will use the formula, that is what? Integration, but listen carefully, the double integration, because here x and y, right? So f of x comma y, that is dx and dy. So how have to put each? You always remember that the limits of x in the form of y. So you are just taking limit of x, that is 0 to infinity, 0 to y. So 0 to y, right? And limit of y, that is 0 to infinity, 0 to infinity, right? Now put the value, and this, because this is joint density function, so value of this will be equal to 1. We have to use this one to find the value of a, right? So we can write here this capital A double integration from 0 to infinite, 0 to y e raised to power minus x minus y dx dy equal to 1, right? Now we have to use next screen, don't worry. Yes, we have what? Capital A integration from 0 to infinite, again integration from 0 to y, right? E raised to power minus x minus y and dx dy equal to 1. So we should solve first what? X. Okay, so we can write here capital A integration 0 to infinite, right? And you can take here minus y outside. You can write integration 0 to y e raised to power minus x dx, right? And dy. Okay, so now you know very well the integration of u minus 1 minus equal, so we can write a minus a integration 0 to infinite e raised to power minus y, right? Now just put here e raised to power minus x, limit 0 to y, right? And what we have to put here dy equal to 1. Now we have to solve. This gives what? Minus a integration 0 to infinite e raised to power minus y. Now put this gives e minus y minus e raised to power 0, that is 1. That is what? Dy equal to 1, right? Now you can just do one thing here, minus a and multiply 0 to infinite. We can write here e raised to power minus 2y, right? And minus e raised to power minus y dy equal to 1, right? Now just you need to do only simple integration. What we have? We have e raised to power minus 2y, right, upon what? Minus 2 upon minus 2 minus plus e raised to power minus y. A limit that is 0 to infinite equal to 1, right? Now put here, so minus say now first upper limit infinite, so e raised to power 0, sorry, e raised to power minus infinite, that is value 0. So 0 minus, again e raised to power minus infinite 0. Now minus e raised to power 1 minus, right, we have this is also e raised to power minus 1 upon 2, that is what here we have, right? So this is what you have to do, minus 1 upon 2, right, we have, that is 1. So 1 minus 1 by 2 we have here what? 1 upon 2, this gives what? Minus 1 by 2. Finally we have a upon 2 equal to 1. A upon 2 equal to 1. So a equal to 2. This first part is solved. Okay. Now we need to go second part. Now we have to find the what? Marginal distribution function of x, right? So you have to write here fx, right, and integration from this is become dy f of x comma y, right? Now you should put the limit of y, where y is varying. Y take here 0 to infinite. Y take here 0 to infinite, right? Now we have the put the value of f x y, so we have 0 to infinite, that is value of a, that is 2 e raised to power minus x minus y dy, right? You can write here 2 raised to power minus e raised to power minus x, integration 0 to infinite e raised to power minus y dy, right? So this is 2 e raised to power minus x. Now this become minus e raised to power minus, sorry, yes, so what I'm telling, this e raised to power minus y, limit 0 to infinite. So you can write here this gives 2 e raised to power minus x only. You can put e minus 0 minus 1 and that is plus multiplication, right? Similarly third one. Now you can check here in third one, this fy of y, again limit of, you have to put x is lying from again 0 to infinite, f of x comma y, and this is will be dx, right? So you can write here 2 times integration 0 to infinite e raised to power minus x e to power minus y, and this is dx. So now you can add 2 e to power minus y, right, integration 0 to infinite e to power minus x dx. Similarly you can write this become also come out after solving, you can write here 2 minus y minus e raised to power minus x, limit 0 to infinite, right? It gives only 2 e to power minus y, right? Now next slide, that is fourth part, whether they are independent or not, you have to check. So independence means you have to just write here f of x y s comma y equal to, right, means joint probability distribution can be written the product of their marginal one, right? not this. So now the value of this, now you can find this value of 2 times e raised to power minus x. This is what? 2 times e raised to power minus y, right? So this become 4 e raised to power minus x minus y. So this does not equal to f of x comma y. So they are not independent. This implies they are not independent. Now fifth one, we have to check the conditional distribution of y when x is given. So you should write first formula. Conditional distribution of y when x is given, you can write in this form. And this will be what? First what? Their joint one upon the marginal of x, right? So this will be what? This is 2 times e raised to power minus x minus y upon, we have 2 times e raised to power minus x, right? So this one cancel, this will cancel. Also one important thing I want to tell you, this is right, we have only here e raised to power, what do we have here? E raised to power minus y, right? This is we have now. So now this is overall your problem. I have done, yes. So this is our answers. I hope so that was problem.